Mass volume problems. So in this situation, we've got an unknown volume being calculated from a given mass. So the path for this is going to be related to grams to moles to moles to grams. How could I screw that up? Grams to moles to moles to grams. But now instead of going to grams at the end, we're going to go to volume. So probably liters could be milliliters. Grams to moles to liters. So unit factors, for the gram-mole conversion, it's going to be the molar mass. For the mole-mole conversion, it's going to be the mole ratio from the balanced chemical equation. And for the moles to liters of gas, the only way we're able to do that is at STP using 22.4 liters per mole, the molar volume of the gas. Now this can also be done in reverse. You could be given the volume of gas, convert to moles of the other thing, and come up with a mass. So we need to be a little flexible. So here's an example. Dilute hydrochloric acid reacts with 0.928 grams of aluminum metal. What volume of hydrogen gas will be produced at STP? So here's our balanced chemical equation. And I'm going to find this number, 0.928 grams of aluminum metal. So that's the aluminum metal. So I'm going to write that mass down here, 928 grams. And it's asking what volume of hydrogen gas. So question mark. It doesn't specify the unit, but liter is going to be the easiest. Liter is a unit of volume. So this is what we're trying to find out. This is what we're given. So then we write out the path. We're going to be grams of aluminum to moles of aluminum to moles of what? Moles of H2, and then liters of H2. Now that I have my path, I can write my equation. When you're starting out, always write the path. After you get the hang of it, you may be able to skip writing the path. But what I'm going to write now, the equation, you should always write out in full with all of the units. 0.928 grams of aluminum. And then I'm going to moles of aluminum. And then moles of hydrogen gas, H2. And then liters of H2. Grams to moles to liters. Then I take the previous unit and put it down here so the moles cancel. Moles of hydrogen cancel. Moles of aluminum will cancel. And then here I want grams of aluminum. So those cancel. Same pattern. The middle one, where do we get numbers for that one? From the equation. So we've got aluminum. There's a 2 in front of aluminum. I'm going to write 2 in front of aluminum. There's a 3 in front of hydrogen. So I'm going to put a 3 there. This term, grams to moles, is the molar mass of aluminum. 26.98? Yep. This is not grams per mole, it's liters per mole. At STP, 1 mole occupies 22.4 liters. Any gas, doesn't matter what gas it is, 22.4. Any questions? 0.928 divided by 26.98 times 3 divided by 2 times 22.4. 3 sig figs gives me 1.16 liters of H2. Let's do another one. Calculate the volume of hydrogen gas produced at STP from 1.55 grams of sodium metal in water, given the unbalanced equation for the reaction. So we have to balance it. I'm going to look at this equation and see that there's hydrogen all over the place. There's sodium is only in one place on each side, so that's a good place to look first. 1 sodium and 1 sodium. Okay, well that was easy. Leave hydrogen for last. He's by himself over here. Here's oxygen. There's oxygen, 1 of each, so we're good. Here we have 2 hydrogens, and over here we have 2 plus 1, we have 3 hydrogens. That's what I call an odd-even problem, right? Because over here, this has to be even because it comes in 2s. And over here, I'm looking for an odd number. So what I'm going to do is I'm going to double everything. So I'm going to put a 2 here and a 2 there, because those are the ones I had looked at. The sodium, and then I looked at the oxygen. Now I have 2 oxygens. I need to put a 2 in front of that one so that I have 2 oxygens. So I was working on the hydrogens when I realized I had an odd-even problem. And so I'm going to double everything and make sure that everything that I had fixed originally is still okay. The sodiums and the oxygens are still balanced. Now I'm going to look at the hydrogens again. Over here I've got 2 hydrogens and 2 plus 2 is 4, and over here I have 4. And so the problem took care of itself. Balanced chemical equation. Question gives us 1.55 grams of sodium metal. So I'm going to write that under its formula in the equation. What are they asking me for? Calculate the volume of H2. So question mark liters. So this is a mass volume problem. It's a variation of grams to moles to moles to grams. Grams to moles to liters. Grams of sodium to moles of sodium to moles of hydrogen to liters of hydrogen. The path is the key. 1.55 grams of sodium. We're going to have 3 factors here. We'll go to moles of sodium. We'll go to moles of hydrogen. And then to liters of hydrogen. I'm going to mix it up and do it left to right this time. Grams of sodium. I'm taking this unit and sticking it in the denominator so they cancel out because I want it to go away. And moles of sodium goes down here, goes away. And moles of H2 down here. So they cancel out. What number do I put in front of moles of H2? 1. How about in front of moles of sodium? 2. That's these numbers right here. 2 moles of sodium forms 1 mole of hydrogen gas. Here we need the molar mass of sodium. 1 mole of sodium is 22.99 grams. And then what goes in this last term? 22.4. So 22.4 liters per mole of hydrogen. 1.55 divided by 22.99 divided by 2 times 22.4. if you don't have your calculator out, you should. 0.755 liters of hydrogen. I don't work all these out ahead of time because I want there to be enough time for you to do it on your calculator. And if that's too boring, play a game with yourself and see if you can catch me making a stupid mistake. It's easier than you think. Any questions? It was one day, I started counting because I made so many mistakes. I made like 9 in 2 lectures. It was just awesome. Do you want to see another one of those, or are you good with those? We're good? Okay.